You ever see one of those big, chunky questions on a GCSE maths paper and your brain just stops? Well, today we're going to tackle one of those head on. We are going to crack the code on a classic simultaneous equations problem, step by step, using the official mark scheme. You're going to see exactly how to lock in every single one of those precious marks. Let's dive in.
So this is the heart of the problem, isn't it? It's the kind of thing that can look super intimidating. You've got a straight line and some kind of curve, and you have to find where they meet. But honestly, once you see the method, you'll realize it's a pattern. And once you've got that pattern down, you'll be able to handle these with confidence every single time.
So, to really get this nailed, we are going to deconstruct a real exam question. This is question 20. By the end of this, you're not just going to know the answer, you'll understand the why behind it and see exactly what the examiners are looking for. We're getting a peek behind the curtain using the official mark scheme.
Okay, let's get to it. Here is the challenge. Question 20. Our whole mission is to solve these two equations at the same time, simultaneously. We're basically looking for the exact coordinates where this line and this curve cross paths.
And here are our two players in this game. On the left, we've got the linear equation, y equals 7 minus 2x. It's a nice, simple, straight line. But on the right, we've got the quadratic. Y squared is 3x squared plus 4. That little squared on the y is the big clue. It tells us we're dealing with something curvy. Our job? To find the x and y values that work for both of these equations. So where on earth do we begin? Well, the most important first step is substitution. This is the key that unlocks the entire problem, and you know what? It's also where you get your first easy mark, an M1. The M stands for method, which means you get credit just for showing you know the right process to start with. It's a fantastic way to get on the board.
And check this out. This isn't just me telling you this. This is the exact wording pulled straight from the mark scheme. This is what the examiner has on their desk. They are literally looking for one thing. Did you replace the y squared in the second equation with 7 minus 2x squared? That's it. That's the first hoop you've got to jump through.
So let's break that down nice and simple. First, we grab that 7 minus 2x from our linear equation. Now, because the other equation has y squared, we can't just plug it in. We have to square the whole thing. So it becomes 7 minus 2x squared. Then we just set that equal to the other side of the quadratic equation. And boom, just like that, we've gone from two equations with two variables to one equation with just x. Your first mark is officially in the bag.
All right, substitution done. What's next? Our new mission is to take this slightly messy equation and tidy it up. We need to expand it and simplify it until it's in that classic quadratic form that we all know and love. ax squared plus bx plus c equals 0. This is an absolutely critical step. First things first, let's expand that squared bracket. Now be careful here. Remember, 7 minus 2x squared is 7 minus 2x times 7 minus 2x. A common mistake is just squaring the 7 and the negative 2x. But if you do it properly, you get 49 minus 28x plus 4x squared. Now we set that equal to the other side, 3x squared plus 4. The last part is just a bit of housekeeping. We shuffle everything over to one side to make the whole thing equal to 0. And what we're left with is this beautiful, clean quadratic, x squared minus 28x plus 45 equals 0. Getting this right bags you a second method mark.
We are so close now. We're on the home stretch. We've got our quadratic, and all we have to do now is solve it. Once we find our values for x, we can use those to hunt down their partner values for y.
Right, it's time to solve x squared minus 28x plus 45 equals 0. Now, you could try to factorize it, but on a calculator paper, your best friend is the quadratic formula. It's safe, it's reliable, and it gets the job done. Using it correctly shows your method, and that's, you guessed it, your third method mark. So we plug the numbers into the formula, push the buttons on our calculator, and out pop our two solutions for x. The mark scheme gives the answers as approximately 26.3 and 1.71. Now remember, these are the two x coordinates where our line and curve are crossing. We're halfway there. But wait, we're not done. Every x value has a partner y value. To find them, we make our lives easy and go all the way back to that simple linear equation we started with, y equals 7 minus 2x. We just take our x values, one by one, and substitute them in to find their matching y value. Nailing this step gets you your fourth method mark. We are so close to the full 5. And here we have it, the complete, final answer, all laid out. two pairs of coordinates that work in both of our original equations. Now, presenting them clearly and making sure you've paired up the correct x with the correct y, that is what secures that final vital A1 mark. The A stands for accuracy, and this is where it all has to be spot on to get the credit. So let's just recap the journey we took. Think of this as your 5-mark checklist. First, you get a mark for correct substitution, then a mark for forming that 3-term quadratic, another mark for solving for x, a 4th mark for finding the y values, and that final accuracy mark for stating both pairs correctly. This is your roadmap. This is how you get full marks on this type of question. So we've totally cracked the how for this one problem. The real skill, though, is learning to spot this pattern out in the wild on other exam papers. As you're practicing, just keep your eyes peeled for that classic combination, one linear equation and one quadratic. The second you see it, you'll know this 5-step process is your key to unlocking all the marks. Thanks for joining me and good luck with your revision.